Hello everyone, welcome. I'm Miriam, and I'm here with my colleague Marten, who is going to talk about FHIR packages.
Hi everyone, welcome to FHIR packages. My name is Marten Smits. I'm a developer at FHIR. I've been working for 10 years already with FHIR and at FHIR, even before we had an official company called FHIR. I started out as a consultant, did multiple implementation guides for different governments, and then slowly rolled into being a developer and now also a product owner for our open source projects. That includes the FHIR.NET SDK, the FHIR Validator API, and also a package library. Today we're going to talk about FHIR packages. And first, I'm going to talk to you about why we actually need FHIR packages before I'm even going to talk to you about what they are. Later, we're going to talk about how to use them and how to publish a package. So before we start talking about packages itself, we're going to talk about how to identify resources in FHIR. So you have your basic instances. Those are always identified with on their location, right? So you have a server, you have a resource type, you have an ID, and you could even have a version history. So if you update a version, it will get the version updated. And you can see that on the left-hand side on the slide here, what it would look like. This works pretty well for identifying resources on your server, referencing other resources on the server or outside of your server. But it wouldn't actually work for something we need to be globally unique, like structure definitions or actually rules about how to define other FHIR resources. You wouldn't want different kinds of US core patients going around and all claiming them to be validated to one. So what you can do in your instance, and you see that on the right-hand side, you will always point to a globally unique identifier for a structure definition called a canonical URI. And that worked out pretty well for a couple of years until we found out this is what it would look like. So you have a patient instance, you have an observation profile that points to a patient profile using the canonical URL. A patient instance pointing to a patient and saying, hey, I conform to that patient structure definitions. So that would be the canonical. And that worked out until we found out that canonicals weren't actually that unique. Even the FHIR spec itself across versions weren't actually using globally unique identifiers for different, well, they were using the same identifier for different kinds of resources. So the patient, for example, here in DS2.1 and DS2.2 would be called structure definition / patient. And you have that with different versions of other IGs as well. For example, US Core doesn't use a different canonical URL for US Core version 6, and that makes sense. So what we did is we added a version to it with a pipe symbol behind it, and you could say, hey, I conform to this specific version of the structure definition. And that worked out great for a while because, well, you could point to a really specific version of a patient resource or a patient structure definition and say, hey, I conform to version 4.1 or whatever. And that, no, okay, let's try that. So what you would have is, again, this patient instance pointing to a patient profile saying, hey, this is version 4.1. And the observation profile would point to a patient as well, saying, I conform to version 4.1. That seems nice. However, that became a little bit messy when you want to update something. So, for example, if you want to update that observation profile or that patient profile, and you say, hey, I'm using 4.2 now, I also have to update my observation profile saying, oh, the patient profile that I am using as well, or I have a subject, of that is using 4.22. So that observation profile would also update their version, and you'll have like an endless stream of trees like updating their versions because you updated one of the versions of your structure definitions. And then I think at DevDays 2018 or something, we discovered this problem. We came up with something called FHIR packages. So FHIR packages actually bundles all of these things that logically belong together. For example, an IG or a set of core profiles that you wouldn't necessarily put in an IG but belong together. And you would version that thing. So then when you are saying in your patient instance you conform to something, you always do that inside of a scope. And that scope is your package. So in this case, this patient instance says, hey, my scope is my example.package.001. And then inside of that scope, it would look for a canonical URL of /structure definition /patient, and we'll find exactly what we're looking for. So that solves a lot of hassle, both for implementers and specification writers, because you don't have to, as an implementer, you don't have to look for where am I going to get my artifacts that I'm actually conforming to. And for a specification writer, you just can bundle everything together. You don't have to update everything if you make one single change. Just up the package version and you'll be fine. So that's why we needed packages. So now we're going to dive a little bit into what packages actually are and what they look like if you download them, or what's inside of a package. So this is a really bad representation of a package. It's actually a tar file, tarball file it's called, and it's basically looks like a zip. You can open it with 7-zip and everything. And it has, inside of it always has a package.json. It's a manifest file containing metadata about that package. I'm going to talk a little bit more about that later. It will have an index file describing everything that's inside that package and how you can easily resolve it. And it would have all of the conformance resources that you actually described. So that's basically the most interesting part. You can think about structure definitions, value sets, code systems, well, whatever you use to describe your use case. And there's also always, you can add examples in it. Basically everything you need to describe your IG or project or whatever. We didn't came up with that ourselves, right? Because this is a problem that exists everywhere in software. In software. So we based it on NPM. We've altered it a little bit to make it as specific as possible for FHIR. But the main things like the tarball thing, the index.json and the package, the manifest, it's all basically the same as NPM packages. The specification for FHIR is on the HL7 website. You can take a look at it, and it's also maintained there. So the FHIR working group is responsible for that. And if there's changes to it, it will always go through that working group. It makes it nice for people who actually use tooling around it. So you can actually know, you have a specification to write for. And one of the main features about packages is that they're always permanent. So if you publish a package, for example, I publish US Core version 4, and a week later I think, oh, I made a mistake. I want to create version 4.0.1. I cannot remove version 4 because there may be other people who actually depend on that package in their software. You can unlist them saying, hey, everyone, I published this package. Please don't use it anymore. But if you're already using it, it's stable. And packages also are used to distribute implementation guide. You will see that here in the US, for example. Every US implementation guide also has a FHIR package alongside of it containing all the artifacts you need to, for example, validate against it. This is what a package manifest looks like. It always contains a name, a version, a description, an author, and dependencies. And the one single dependency that you always have to add is which version of FHIR you're using. So that will be the first one here in this picture. It doesn't have to be the first one because it isn't ordered or anything. In this case, this package has a dependency on hl7.fhir.r4.core, version 4.01, and that's basically saying that this is an R4 FHIR package. You can add different dependencies. We're going to talk a little bit more about that later. But basically, you can add like dependencies on top of, so you write your specification on top of other specifications. There's also some other attributes you can add, like these are not mandatory attributes. For example, for IG packages, I think there's a couple of more that are mandatory, but normal FHIR packages, which aren't necessarily IGs, don't have to contain those. So how do I use packages? I mean, it's all fun and games that are packages, but how do I actually use them inside of my project, or how do I create one? So finding packages, I think that's one of the most important things, right? So where can I find these things? There's a website called registry.fhir.org, which you can use, which has a UI where you can simply, like a Google kind of way, has a search bar. You can look for whatever packages there are, and you'll find them all there. That's built on top of simplify.net, which we discussed with HL7 International to be used as like the backbone of the package registry. And Simplifier actually pulls a lot of package feeds. There's not a lot of them. I said a lot, not a lot of them. HL7.org has a package feed, and package feed is more like, if you know what an RSS feed is, looks a little bit similar like that. So HL7.org has a package feed containing a list of the packages they want to distribute, and Simplifier pulls those and publishes those to the rest of the world. And HL7 terminology has a kind of them. Simplifier itself has a way to publish packages, and there may be others as well. And you can easily add your own package feed to Simplifier as well. And I think you just have to file a pull request against some GitHub repository containing your package feed, and you're good to go. Next to registry.fhir.org, which is more of a UI to find packages, we also have an API. So packages.fhir.org is that API, and it's you can pull packages over there or find them using software. So if you want to install a package on your local machine, you can use that by you can do that with npm, just like you would do with node packages. That's the easiest, I guess. But you can also use FHIR terminal for it. And I added a picture here how to do that. You just do FHIR install package name, and it will install all of the packages and their dependencies that you need to actually have these artifacts locally. They will be installed inside of your user profile, and we discussed that with all the other tooling people, that will always be, and it's inside of the specification itself. In Windows, I think it's in your user profile. There will be a FHIR folder where all your packages are, and in Mac, I think it's on your root, but I'm not sure. You can also install packages on your FHIR server, but that depends on the FHIR server you're using on how to do that. So basically just consult your FHIR server provider or your developers on how to do that. So next, you have installed your packages, and you want to build something new on top of them. And this is more for modelers in this case. You have all these modeling tools like the IG Publisher, FHIR Shorthand, Forge, and they have all been incorporated in this package like infrastructure. So inside of Forge, you can, when you start a new project, you can say, hey, what are my dependencies for this project? I want to build something on top of US Core. Inside of the tool, it will be able to add that specific package, and it will install it the same way like all the other tooling do. So they will download those locally, and you can build on top of them. And the same thing goes for IG Publisher and FHIR Shorthand. FHIR Shorthand, you have a dependency element on top, and you can say, hey, these are my dependencies, and on the background, it will install those packages for you. Same goes for IG Publisher. So that's nice. Now you have FHIR packages locally, and you know how to build on top of those. And you can add your own rules, create more structure definitions that build on top of them, use every artifact inside of it, so you don't have to duplicate those.
We're going to ask everyone to come back to the front.
Apparently. Don't go to the front, please. And then after that, you have built your specification and you want to create your own package. You can do that using the command line. So you have all your structure definition locally, or using Forge as well. And you just, in FHIR terminal, you say FHIR pack. And what will happen in the background, it will create a package file for you. Now you have that locally, and you can publish it as well with FHIR terminal. But what you can also do is package your simplifier project. So if you're working with simplifier and you've put all your structure definitions there, you've written your IG, you've done everything, there's a UI that will help you create a FHIR package and publish it using simplifier as well. If you're using IG Publisher to create all of your structure definitions, IG Publisher automatically generates a FHIR package along with the IG you are publishing. So everything is taken care of here as well. The tooling will help you creating actually packages. There's a couple of things you want to know, or there's a couple of conventions actually when creating packages. You have to think of a name, right, for it. And there's a couple of conventions there. Most people will do this for a specific region. Well, most government will do that. For example, the UK core or the German Basisprofil over here. So they will start with their region, then a subject about what they're talking about or what they're describing. And everything has to be chained with dots. People might also want to add their own like author or organization. And you can do that. So put those in front, then add the subject, and then and also separate those with dots. The versions inside of packages are always semantic version. If you don't know what that is, it always starts with the major version, then the minor version, a patch, and maybe a label for annotations. Up the patch version 1 by 1 if you just solved like a typo or whatever. If you make a more extensive change, but didn't actually break the package, you can do a minor version. And if you break the package, it's not backwards compatible anymore, then you have to up the major version by 1. Then also, we're talking about dependencies here. If you're creating packages, you're building your package on top of other dependencies, right? So in this case, your new package on the top has dependencies to US Core 6, Terminology 3, 3.1, and some other super cool package, whatever. Doesn't really matter. And you can reuse those artifacts inside of your package. So if people use your package as a scope and they're searching for a US core patient, for example, they have an instance patient profile and they want to confirm to US core patients, they can find that using your scope because it's inside of your dependency tree. Now, there's a couple of difficulties here if you make it difficult for yourself as well. So please bear with me. For example, in this use case, you want to depend your package on some super cool package 1.00, which has a dependency already on US core 6. However, inside of your package, you also want to use maybe a value set or some specific other artifact that comes from US core 5. Now, you are adding those dependencies here. You use your super cool package, everything aside, all fun and games. But then a user of your package wants to resolve or wants to validate against US core patient. And it doesn't really know, I mean, it could see that you have multiple versions of US core here. And then tooling wants to resolve that structure definition from your scope. Now, there's not clear specification on how to do that. So for tooling people to know how to actually resolve those. Should it resolve the US core 5 one? Should it resolve the highest version, like really down in your dependency tree of US core 6? It doesn't really know. So if you want to make sure in this case, use a version, pipe version, you can still use that to make sure I want to resolve this against 0.1. But these are discussions that are still going on inside the community. They're going on Zulip. If you have a real strong opinion about it, please join. And actually, in this case, the different tools inside of our community do this differently. So if you have a problem with it, please come to us and ask for help. The same thing goes because some people think it's a good idea to create a package directly on top of multiple versions of US core. And that can be the case because you want to write text on how to use your package in combination with multiple versions of US core, right? I mean, you can argue that and saying, for example, my implementation guides, if you use my profiles inside of US core 5, do it this way. If you use it in US core 6, do it this way. So you will have multiple dependencies. This is currently not possible to do with tooling unless you are using a hack. For this to work, tooling needs to implement aliasing to make sure, you can actually describe how to do this. And what will currently happen if you search for this US core patient, in almost all tooling, it will just find the highest version, 6.1. And if you want to use a lower version, you have to use the pipe. So if you want to use US core 5, say US core patient / or pipe 5. And that will help you resolve all the artifacts in your scope. But please don't go here. So the last thing I'm going to talk about is how to publish a package. You have your package now created using Forge or IG Publisher or Simplifier or whatever tools you do, and you want to publish it to the registry. You can do that using simplifier.net. There's just a button to do it. That's easy. You can do that. The IG Publisher can do that. If you go through all the balloting process and it's actually published, it will also put your package automatically inside of the registry. Or you can do it yourself with your own package feed. If you want to do this internally, for example, you don't want to publish your package to the public FHIR registry, I can imagine that. You want to keep it for yourself or make it private. You can have your own package server. You can create it. Thanks. And for the .NET users, there's a library available that can help you do that. It's open source. It's on GitHub. It's not very well documented, I'm sorry. But if you have any questions about it, please reach out on GitHub or tag me on my shoulder or whatever, and we can help you with that. I've been going through this way too fast because it's already Q&A time. So if you have any questions now or later, now we can just go with the mic through the room. If you have them later, please send me an email, file an issue on GitHub if it's about the library, reach out on chat.fhir.org. Well, I'm open to it. So there you go. Thanks.
Just for fun, I would be interested how many packages have been published over the years.
At all?
Yeah.
Oh, wow, we can find out. I don't know. Shall we take a look? Let's see. I don't know if there's numbers.
Maybe Simplifier knows how many packages Simplifier has.
It's the same, right? So it doesn't really matter.
It sometimes has these numbers, order numbers. Oh, no projects.
No projects. Well, there's around 7,000 projects on Simplifier,
Yeah, but not all.
but not all have packages. I don't know, a couple of hundreds probably, like real using packages.
Well, we mess around with packages, so there might be alpha, beta versions so many times. So
Right. Well,
Marten, I've got a fairly specific question. Maybe
Sure.
it's too specific, I don't know, but we can see. But when I'm working with tx.phir.org, it pulls in, terminology from the packages, repository. And so phir.tx.support.r4 package in
Right.
particular. And I've always run into this issue where I can go in and I can make an update to one of the code systems or value sets in the package and take care of that on the GitHub end. But once that's there, it doesn't immediately get up to the server, the terminology server.
Right.
And Graham sort of always has a bit of magic that he does, and I never had the ability to actually push it through the last step, and I kind of work around it sometimes, so but otherwise it's a little bit of a bottleneck. And I don't know if I'm missing something or if there's, if you have any answers.
we have to check it out probably later. I don't know it by heart,
okay.
so.
Well, I thought it might be too specific.
Oh,
but yeah.
sure, but we can find it out.
Okay.
thank you.
My question is regarding delisted packages. So once one of these is out in the wild, what happens when a tool encounters it? So let's say you have a validator running or you have a FHIR implementation and there's a delisted package listed
Right.
somewhere.
So if there's an unlisted package and your validator encounters it, it will still work because it's not gone, right? So it can just download it. It can put it on locally. It will just, for example, if you build on top of it, tooling will throw a warning and saying, hey, you're building on top of an unlisted package. You might want to think about upgrading. Because some people wouldn't, right? I mean, I can imagine that if you have like really stable software built on top of an unlisted package, someone unlisted it and made breaking changes to it, and you think, I don't want to go making breaking changes inside my software because it's really stable, right? So I'll just ignore this and I'll keep building on top of this unlisted package. But there might be a reason that authors unlisted it. So there might be a security error inside of it or something like that. So I think it's basically the user's responsibility to upgrade to another one, but otherwise, if you don't do it, it will work exactly the same.
Anyone else?
Over here.
So it seems like, when you're creating these packages and sharing it on FHIR registry or trying to put it out there for public use, makes sense. You can pull that down and use it.
Right.
But what would you say if do you need to create a FHIR package or keeping things internal and not necessarily trying to distribute it even within the company?
Right. So then you can create your own package server. Don't put it out in a registry because everyone will be able to take a look at it. But if you create your own, for example, a lot of companies have their own NPM package servers, right? You could do the same thing with FHIR package servers just to keep stuff internally. And there's tooling around it to help you. And then you can use the same tooling to actually, within your company or within your closed source, you can use the rest of the tooling just as well, just change the package feed.
Following up on that question, is it possible to save the packages in our own NPM server?
Yes,
So that
you can.
Okay.
Yes, that will actually work.
Okay. Thanks.
I think you will miss a couple of features that work with our tooling right now, but you can just install them on the package server and download them and everything. All of the normal stuff you will usually will work as well.
Okay.
All right.
No more questions, it seems.
Oh.
So I want to thank you, Marten, for this presentation.
Thank you. Early break, I guess.